So anyway, in the last one, we check if we want to solve this one that we checked before. You're going to get the imaginary solution. And what about this step? That's all I need to know. If I start from a minus I equals 0, then I have the negative 2 minus r, negative 2, and I get a negative 2. Then it's r squared minus 6r plus minus 8 plus 2 equals 0. No, minus 2 plus, that's minus 2. And then this solution is r minus 1 squared equal negative 1. And you get that r equals 1 plus minus I. That's your eigenvalue. And what's your eigenvector? That's a little messy if I come back to see the next one, I think. Oh, this one, yeah. No, not this one. Oh, this one. What we get is t cosine t sine t, that's right. And we got 2 of those eigenvectors. One is 5. Let me see. I think I probably don't. Probably it's easier for me to solve it. Okay. So I only need to solve one in this case. Maybe I need a few more minutes. Then the other one comes automatically by conjugate. So if I put this r equal 1 plus I, and then negative 2 minus 1 minus I, 5, negative 2, 4 minus 1 minus I, and reduce this, it's negative 3 minus I, 5, negative 2, and 3 minus I, AB equals 0. Believe or not, this one is really the same equation. You have to be the same. So you select the one to get the other. So I'm going to select the negative 3i of A equals 5 plus 5b equals 0. I only need the 1. So what I get is the 5b equals 3 plus IA. Now how do you solve it? Easy. You have one freedom. Let A equal 1, 5 to make it nice. Then B equals 3 plus I. Then your solution is 5, 3 plus I, which is 5, 3. That's your real part A. Your imaginary part, take the I out, 0, 1. That's the B. Can you see it? So we solved it. And once you solve that, and your solution will be a little complicated. See, exactly like that. 5, 3. That's the solution look like. And then your solution will be have C1 and C2. You use the initial condition to solve the C1 and the C2. My solution look like this. E to the t cosine t 5, 3 minus sine t 0, 1. That's the first one. And the C1. C2 sine t 5, 3 plus cosine t 0, 1. And then you got this solution. The only thing you do not know is the C1 and the C2. what you're going to do is let t equal 0. If you let t equal 0, your solution, that's 1, and that's 1, that's 0, 0, 1, and you get C1, 5, 3, plus C2, 0, 1, need to equal your initial condition. What is it? 5, 3. Of course, then your C1 equals 1, C2 equals 0, you solve the problem. And then what's your solution look like? This is 1, that's 0, then it's ET cosine t 5, 3 minus sine t 0, 1, which is exactly what we had. ET 5 cosine t 3 cosine t minus sine t. That's the final answer. That's exactly what we checked before. And finally, we finished this with 5 minutes longer than I like. And what we learned is we can do by hand, but we don't have to be doing it by hands. You can use MATLAB and Maple. Unless you understand how you do it by hands, that answer even give you all nonsense, you wouldn't know right from wrong. So we need the basic knowledge. I left quite a few exercises for you to really get the knowledge. One thing I want to emphasize is the eigenvalue and the eigenvector. And now you see how it reconnected again. And we use that concepts solved differential equation. And the last time we used that concept, talk about geometric attribute and for transformation. For example, if you have an eigenvector, it does not change direction. So in the dynamic system, if you have an eigenvector, the same idea. If you have a current flow in that direction, the current won't change direction. It just go either forward or backward. Just like a magnetic field, every other field could turn in direction. But anything on the eigenvector and the eigendirection does not change direction. We can talk many more hours, but we stop here today. Thank you for your participation. See you next time. We're going to turn to the non-homogeneous equation with another term, and we're going to solve 1 or 2 simple ones by hands. Most use the Maple and the MATLAB. See you next time.